Dear students, welcome to VidyaVardhini Academy. Today we will discuss about a problem from the chapter Electric Potential and Capacitance. The problem is like this. A copper wire of length 50 centimeter and diameter 1 millimeter carrying a current of 3 amps. The number density of free electrons in copper is 8.5 into 10 raised to 28 per meter cube. Calculate. The first one is current density. Second one, we have to calculate the drift velocity of free electrons. Third one, we have to calculate the time taken by the electrons to drift from one end to the another end. Okay, this is the problem they have given. In the problem itself, they have given the length of the problem, the length of the copper wire, that is L is equal to 50 centimeter they have given. Along with that one, they have given the diameter of the copper wire, that is D they have given. D is equal to 1 millimeter they have given. Okay, convert this to meter. If we convert this one to a meter, it is equal to 1 into 10 raised to minus 3 meter. If we convert this length 50 centimeter into a meter, then it will be 0.5 meter. Then they have told that the current passing through this copper wire is of 3 ampere, that is I is equal to, I they have given, it is 3 ampere. Then they have told the number density of the free electrons, means the number of electrons in that copper wire. They have given that one, N is equal to 8.5 into 10 raised to 28 per meter cube. Okay, then they have asked us to calculate the current density. Current density is J, we have to calculate. J we have to calculate. Drift velocity, that is Vd we have to calculate. Then time taken by the electrons to drift from one end to the another end, that is T we have to calculate. These three things we have to calculate, and we also know that the charge of an electron E is equal to 1.6 into 10 raised to minus 19 coulomb. This is the charge of an electron. So first one, what we have to find out? First we have to find out A, that is current density. We know that current density J is equal to the current passing through the cross-sectional area, I divided by A. Okay, but we don't know area, that is area of cross section of that conductor, that we don't know. Okay, therefore we have to find out A. Therefore area of the cross section of the conductor, that is A for this wire, is equal to pi d square divided by 4. It is equal to, that is pi is 3.142. D they have given, that is diameter 1 into 10 raised to minus 3 whole square divided by 4. This will be equal to how much? It is 7.85 into 10 raised to minus 7. Since it is area, meter square. This is the area. So now we can calculate for current density. J is equal to I divided by A. I they have given, that is 3 ampere. 3 divided by 7 into 7.85 into 10 raised to minus 7. This is equal to, J is equal to 3.82 into 10 raised to 6 ampere per meter square, because here the current is in ampere and the area of cross section is in meter square. Therefore the SI unit is ampere per meter square. This is for current density. The second, they are asked to find out the Vd. Vd means drift velocity. They are asked to find out drift velocity, that is B. We have to find out Vd. We know the formula for drift velocity. Vd is equal to J divided by N into E. Okay, J is current density. Just we calculated the current density, substitute that one, 3.82 into 10 raised to 6 divided by number of electrons they have given, it is 8.5 into 10 raised to 28 into charge of the electron. We know the charge of the electron, it is 1.6 into 10 raised to minus 19 coulomb. Okay, just if we solve this one, we are going to get the drift velocity Vd, it is of 2.81 into 10 raised to minus 4. Velocity, it is meter per second. Meter per second is the SI unit. Okay, then they are asked the C, the problem in the problem we are solving for C, that is time of drift. We know that T is equal to time taken for that one is the length divided by Vd, drift velocity. Length they have given, the length of the wire, it is 0.5 meter divided by Vd. We know that drift velocity, it is 2.81 into 10 raised to minus 4. Therefore, the time taken by the particle to drift is 1.779 into 10 raised to minus 3 seconds. Okay, this is the time taken by the electron to drift. This is the 5-mark problem. Okay, for more problems, just follow our YouTube channel. Thank you so much.